same materials burn, right? So we have that light gray smoke, that white smoke, because we're increasing the temperature of those materials. It's starting to pyrolyze. It's starting to off-gas a little bit, starting to get rid of the moisture. That's what you see there. As this fire grows, right now, the only way for that fire to get its air is through that hole in the front, right? We're going to cut the grass. I'll have to talk even louder, right? So that fire needs heat, it needs fuel, and it needs air. The only places that fire can get air from right now is that hole in the front of the box. And when you go to your fire grounds and you start sizing up your fires, you have to try to figure out and look at where's that fire getting its air from, because that will help you with your tactics. We start thinking about controlling the door and controlling the air. We're looking at controlling the building through limiting the amount of air in. So as this fire is growing, a couple things you want to look for is you want to look at what's the neutral plane. That's that line. Some of you may hear the thermal layering and thermal balance, right? That's that line of the smoke, heat, and fuel, and below that is the fresh air. Because right now, that's the only place it's getting its air from. So the smoke, heat, and fuel are coming out the top, and fresh air is coming in the bottom. So at that door, at that opening, we have bi-directional flow. We have heat, smoke coming out, we have fresh air in. So we have two directions of flow. You'll see that right now the fuel's kind of burning a little bit slow, it's a little bit light, and as this progresses and as we move on, the smoke will increase in density, will increase in velocity, and it will also, the neutral plane will start to drop. The lower the neutral plane drops, the closer to flashover we are. Once it takes over greater than 50% of that doorway, we're approaching flashover. So you can use that as part of your size up. As we start to look at the fire ground, we start looking at our doors for fire attack. If we have a neutral plane up nice and high, and now all of a sudden that neutral plane is dropping, we're approaching flashover. But if all of a sudden we're at that door, we're ready to push in, right? And that neutral plane rises, that means we have ventilation somewhere, because we got that lift that we've always heard about. And that lift is good because it's allowing ventilation, but as we get that lift, what's coming in? Fresh air. What does fresh air do to the fire? It grows, it feeds it. So now there's some instructors, we've heard it for a while, that vertical ventilation is no good. We shouldn't be doing vertical ventilation, right? I like vertical ventilation. It has its place in the fire ground if we can apply water. Because we've been taught for many, many years that ventilation equals cooling, right? Ventilation does not equal cooling. Water application is what equals cooling. So if we're going to vent the structure without water application, all that we're going to do is create a real big fire and we're going to burn the building down. So we have to control the building by our ventilation. So as you see, we have Jeff here on the left, we have Keith Snyder over on the right. They're playing with the door opening here. They're playing with how much oxygen they're allowing into this compartment. And that fire's compartmentalized. It's only in that lower left compartment. Now Jeff's not going to, because this box will take a little longer to go, but if he closed that compartment down all the way right now, what would happen to that fire? It would go out. And that compartment is not airtight, but we limit the air so much. Jeff's going to go ahead and we have burning plastic materials. He's going to throw in some styrofoam. Another lesson for you to bring back to your department is to show the difference of fuel loads and the difference of smoke. Talk about reading smoke and sizing up your opening. Because he threw that styrofoam and now he's going to close that compartment down to about there, maybe a little bit more, depending on what the smoke does. Jeff's going to read it. You're going to start seeing the smoke is puffing a little bit there, but the smoke is going to get darker. It's going to get denser. It's going to increase in velocity. Right? Those are the things that you should be looking at in your fire ground for velocity, or the speed that the smoke is traveling, the density, the color, right? Because the darker the color, it means it's more fuel rich. So if Jeff took this torch right now, which Jeff is going to take this torch, he's going to try to light this smoke off. Do you think it's going to be successful? What do you think? There's fuel in that smoke, right? It has plenty of oxygen, so what's he doing now with this torch? He's going to add it to the smoke, and he's adding all the heat that it needs, right? Look at that neutral plane there. See the air getting sucked in? He's added plenty of heat. Why is it not lighting off? It's not rich enough. It's too lean, right? You're definitely on the right track. I like that. We're going to do this again afterwards once that smoke gets really, really rich, and show you how we can light it off by just creating the right mixture of the fire tetrahedron. Everything comes together. So you can see that one inlet, that outlet's kind of fighting for itself. We have some really nice unidirectional, bi-directional flow there.
You guys up, man. If you guys want to slide over here for smoke's killing you.
switched over here.
The wind changed on us just a little bit.
So we had some really nice bi-directional flow coming out of in and out of that opening. See the neutral plane there is real nice. What we're going to do is we're going to open up number 3, just the front door. All right, but remember, that compartment is not connected to the one on the left. So now that compartment is charged with smoke because the OS&B is starting to off-gas and filling that. Now it's kind of just slowly drifting out of that compartment, right? But now, even if we close down the lower left, which Jesse goes through now, really not going to change that compartment on the right, except just lowering the temperature a little bit. So now we're going to open up one just a little bit, keep going and open up that door, go from left to right. Now we're opening up that compartment, the door in between lower left and lower right. So now we're going to see some changes. We're taking that compartment, we're doubling the size, right? Close down one, Jeff. See? So now as Jeff closes down the lower left, lower right there is now our inlet and our outlet. That's where the fire, smoke, and heat gases is venting. It's also where it's getting its air from. So now the air is traveling from that side of the box to this side of the box. So it's going to take a little bit longer for that fire to grow, because it takes a little bit longer for that air source to get back to the base of the fire. But it's the same thing. It's just the compartment's double the size, right? So now if Jeff opens up number 1 a little bit, you'll see some changes possibly as 2 happen. You'll see that neutral plane potentially change because the size of the opening has changed, right? So now we have a good fire going in 1. Jeff's going to close that down. And as he changes that, you'll see that neutral plane is still defined, but the smoke changed a little bit because we changed the amount of air. And we'll start seeing that neutral plane drop a little bit. We'll start seeing that smoke get much more dense and more velocity. We'll start seeing at some point get a little turbulence. That turbulence is where that neutral plane is, where you have everything exhausting and that fresh air coming in. As that fire wants to grow fast, the air track speeds up and it creates turbulence, where the two is creating friction, where they're going bypass each other, and that's where the turbulence comes from. So now all that they're doing is they're just controlling this fire. They can let this fire burn for over an hour by just limiting the air. You're going to see we're going to get it going, and we're going to really get this to speed up as the more air that we supply. But as heat keeps off number lower right there at 3, we're eventually going to have what in that compartment? We're going to have fire. We already saw it lighten off a little bit already. We have a little bit of a breeze now that we didn't have this morning. So that's going to change up conditions a little bit for us. So it's not really a wind impact fire, but the wind is going to impact our fire behavior. All right, so Jeff, open up 1 halfway. So as he opens that up, he creates more air. So we start getting more fire. And now you see that over to the right, you see the smoke change. This compartment, shut that down. What we're going to do is now we have fire coming out over to the right. You see that change as soon as Jeff. Now Jeff, open up 1 real quick. Watch that 3 change. All right, we had a little ventilation induced flash over there. So close that down. Now let's open up number 3. Now the same thing here. He opens up just the front. Yeah, just open up the front and turn the top right. That's going to be charged with smoke, but we're really not going to have a neutral plane there because the floor is not open. Right? There's nothing burning in there. That's just the off-gassing from the OS&B. But now as Snyder reaches in and he takes out the floor for number 3, the top right, we're going to see a big change in the velocity and density of that smoke. Look, we already have fire coming out into 3. So let's close up 2. Lower, sorry. I'm screwing you up. Don't keep that. We're just going to do this in front. I'm sorry. That's
Keep in mind that the hot gas is flowing, heating up the structure. So at some point, the structure itself will become part of the fuel.
So now he's playing with the opening. So now we're going to open up upper right. I'm screwed up because I started giving him numbers. The rest of the day I was giving him upper right, Laura. Yes. So now as he opens that up, watch this compartment change. The lower left is going to turn into a complete inlet, and up top right is becoming an outlet. See, we don't have a neutral plane in the upper right. Close down now, lower left. We'll see top right now change. Now we see that neutral plane because now it's fighting itself. It's an outlet and it's an inlet. As we open up lower left,
you see the flames, by the way. It's only flame outside of the opening. There's no flames inside the room.
Correct. So now Jeff is going to open up again lower left, and we're going to see that compartment flash over. But ventilation always equals cooling, right? That's what we were taught. Is ventilation equal cooling here? No, this is the same as your fire ground, just smaller. So now, if Snyder opens up lower right and close down left, open that, we'll see the same thing happen. we just see things change. We see the where the fire moves changes based on where we're ventilating. So let's close it all up. Right, so now, open up lower left a little bit. Good, so now we're going to move to roof ventilation before we actually lose the box, right? So now, we've always been taught, when we have a building choked with smoke like this, we vertically ventilate. So we're going to cut a hole in the roof, right? So Keith Snyder's cutting the hole in the roof right now, which is great, but that really doesn't do anything for us until, I heard it, until he actually goes and pushes down the sheetrock. Now watch this change of this pressure. Yeah, open it up. A little less pressure now, right? Now close that. Watch the pressure change in the front of the building. Now we're choking that fire out. We're choking that building with smoke. So now he's going to open up that sheetrock again. Watch this out. Watch this change down here. That fire off the outside. So what we did is we got that lift, right? We got good lift up off the floor, but as we get that lift up there, what's happening in the front? We have a nice neutral plane there, right? That's getting its air. What's happening to the upper top? Just look at the smoke. What's happening to the temperature? It's going up, right? So vertical ventilation is a good thing for your fire ground. It gives you that lift, but it doesn't equal cooling without what? Water. Without water application. We're gonna open up two. Let's see what happens when we open up the top right. Look at that sucking in there. That option is going in, traveling all the way back down to the left, feeding that fire. Now open up lower left. Watch that compartment change. A ventilation induced flashover. And all that we did was control the opening. Close lower left. Close top right again. Close the roof. Alright, so open it up. Yeah. Yep. Now we're going to burn Keith. So now this is happening a lot faster. You guys can just play with the openings now. You can see that this is happening a lot faster than it will in your fire grounds because it's smaller, but the exact same thing happens on the fire ground. Just go to YouTube and now look at the buildings and look at actual private dwelling fires. You're going to see this exact same thing happen, just on a little bit bigger scale. So at this point, Keith and Jeff are going to play with the openings, and Sean is pitching it off here.
All right, so as things are starting to light off right here, our line of duty depth is right behind you. Firefighter Steven Sullivan from Atlanta. It's exactly what happened to him. 900 square foot board up building, brick, everything's boarded up. Truck gets there, what do? Got guys on the inside, we got to pull the boards off. Pull the boards off, you saw them, they pulled the boards off too. Lit off on them. Yeah. Instead of staying low and getting out the front door like the rest of his crew, he stood up, got nervous, died 6 days later in ICU, okay? And it's all because ventilation induced flashover.
So what they're going to try to do now is light off the smoke, right? So they're going to open up, it's lighting off on its open. So try that top left. Yeah, look, it's lighting itself off, right? Just from the radiant heat. So we don't even need the torch. We're going to use the torch to show you the difference from how it would light off earlier today, but it will now. There's just way too much